Assalamu alaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIVS Home School. I am Sabreena Haque, Assistant Teacher of Science, National Ideal English Version School, Day Shift. Dear students, today I am going to take a chemistry class for class 10 student based on chapter 8, and this is the part 1 of the chapter, and this is also reviewing the part 1. Already we have take one class in your previous class on this part. Dear students, name of the chapter is Chemistry and Energy. This is the important chapter of your book, and in only one chapter, in that chapter, the chapter title name is the chemistry with your subject name, and we know we get most of the energy from the chemical things. That means chemical energy we take as the food. That's why we are just discussing about the energy in the chemistry. Now chemistry here, because we are discussing about the energy in chemistry, so the first lesson's name is chemical energy. The source of chemical energy is the first point. And matter has molecules and atoms. We all know this. An atom remains connected to another atom because attraction energy, and this is the bond. This bond is the main source of the energy. Similarly, a molecule remains bonded with another molecule due to another kind of attraction, that is intermolecular attraction. That also another source of energy. That means when we break down any chemical that or any thing, that bond energy we will get as the source of the all energy. This energy is called chemical energy. Now come to bond energy. In chemical bond, the energy by which an atom remains joined with another atom is called the bond energy. The energy that acts to join together atoms, that is in these cases maintains the bond energy. That means maintains the bond, which is if this is the hydrogen molecule, the hydrogen has a bond. If we break this bond, we will get the energy which is involved to make this bond. This is the source of the energy. Now come to the intermolecular energy. In a covalent compound, the energy that keeps the molecules combined with each other is called intermolecular energy. Now what is a covalent compound? Intermolecular energy combines the molecules of surroundings water with a molecule of water. Then on the other hand, in the ionic compound, sodium chloride if it is a sodium and chlorine, but if it is a crystal of sodium chloride, one sodium is surrounded by 6 chlorine ions, like this way, and one chlorine is surrounded by 6 sodium ions, and both are opposite charged, and that's why their attraction force is very, very strong, and that's why the ionic ionic compounds, the intermolecular attraction energy is more than the covalent compound, and that's why their boiling point and melting point is higher than the covalent compound. And another thing is, in the room temperature, because of this intermolecular energy and the bond energy, they remain solid, and the covalent compound remains liquid or gaseous states. Now come to the transform of energy in chemical reaction. Dear students, when we take food as chemical energy, but the main source of all energy is sun. The solar energy trapped by the plant when they make their food through the photosynthesis, they convert the solar energy into chemical energy. That chemical energy plant also use, and we also, other living organism also use, and that chemical energy when we work, we need the energy. That time we, like now we are I am talking, we need mechanical energy, sound, it produces also sound energy and also heat energy. Then this energy, three types of energy we get from the chemical energy. Here they are saying about the transformation of energy in chemical reaction, about this, and this all the changing of energies is going through a chemical reaction. Now come to unit of measurement of energy. We already learned in our previous classes, that means calorie or kilocalorie was used as unit to measure energy. The heat applies to raise the temperature 1 gram water 1 degree Celsius is called calorie. Now 1 kilocalorie is 1000 calorie, and kilocalorie is expressed by kcal. Now in the international standard unit, that means SI unit, measured all kind of energy is joule. A joule is, this is the definition of joule. A joule is work done by a force of 1 Newton acting through 1 meter displacement, and this is the definition of joule. It is expressed by abbreviate J, small j. 1 kilojoule is equal to 1000 joule. Now here the relation between calorie and joule is equal to 1 calorie is 4.18 joule. Now classification of chemical reaction or change of heat in the chemical reaction. Dear student, in the chemical reaction chapter we already learned there are several types of chemical reaction, and through the generation of heat we can divide it into two types: exothermic chemical reaction and endothermic chemical reaction. And here exothermic chemical reaction, the value of del H is negative. And what is del? H is heat and del is the how much heat is produced or absorbed. This is the del H. That means here we already learned this formula. Again we will use this formula from the chemical reaction chapter to the chemistry and energy chapter. That means del H is equal to total internal energy of products, that means E2, and minus total internal energy of reactant. Now dear students, two things you have to remember, that is this portion you have to learn, and another thing, in the exothermic reaction, come to the exothermic reaction. In the exothermic reaction, the reaction place will become hot. That means heat will evolve that through the reaction. That is the definition of exothermic reaction. Chemical reaction in which heat is evolved are called exothermic reaction. Dear students, that means because here heat is evolved, that's why the reaction place will become hot, and here they produce the heat. But you have to remember that value of del H here will be negative. Look, this is the natural gas. We know methane is in a natural gas which we use as fuel for cooking and other things also. Now we get a huge heat from that, and when methane in presence of oxygen react with each other, we get carbon dioxide, water vapor, and also a huge amount of heat. From where this heat comes? From that bond. That means here this is the methane, one carbon is bonded with 4 hydrogen, and here oxygen double bond, and when we break the bond, and here the carbon react with oxygen become carbon dioxide, and this hydrogen is react with, that will be 2, this hydrogen will be react with oxygen from here and produce water as water vapor, and then we get this portion of heat here. That means here this is E1, E1 is greater than E2. When we subtract a greater number from a smaller number, that time the result will be minus. That means del H will be negative here. Look, Here the bond energy of methane and oxygen is more than bond energy of carbon dioxide and water. That's why the bond energy of, or energy which is hidden in the reactant, that is greater than the product. That's why when we subtract the greater number from the smaller number, we will get the negative value of del H. Always the value of del H in exothermic reaction will be negative. Now come to the endothermic reaction. Dear students, if you go to the coastal area, you will observe that outer crust of the oyster is cooked or boiled with the water, and by applying heat, and through this procedure they make the calcium carbonate, because 98% of outer crust or shell of the oyster has the calcium carbonate, and this is the edible calcium carbonate which we eat with betel leaf. And look, there we have to apply heat for getting the calcium carbonate from the oyster oyster crust, and the here a lots of heat is absorbed and we get our product. Now come to the reaction. This is calcium carbonate. We have to apply heat 176 kilojoule per mole, and then we will get calcium oxide and carbon dioxide. And here heat is required 176.8. Dear student, here the bond energy of calcium carbonate is less than bond energy of calcium oxide and carbon dioxide. That's why we have to apply heat here. Here reactant is E1 is smaller than E2. That's why when we subtract E2 from E1, that time we will get the positive value of del H. That means when we subtract a bigger number to a smaller number, that time we will get the positive value. That's why in the endothermic reaction always the value of del H will be positive. Now dear students, come to next one, the calculation of heat change in the chemical reaction using the bond energy. The value of del H in our chemical reaction determined in two ways. That two ways we have to remember. This is also we get in chemical reaction chapter. Here we also again get that first one we have learned in the previous page, the total energy of products minus total internal energy of reactant. And then come to next formula, that is total bond energy of reactant. It is B1 because bond energy, this B is represent for bond, minus total bond energy of product. And come to next one, the energy required for breaking the old bond, that means B1 minus total energy released in the formation of new bond, that is B2. Now come to next page. That means in exothermic reaction B1 is lesser than the B2, so value of del H is negative, and in endothermic reaction B1 is greater than B2, so the value of del H is positive. This total portion you have to remember. This is too much important for your MCQ and knowledge based question. Now dear students, here they give some bond energy. They give the bond and their energy. Look, in the methane we break down 4 carbon hydrogen bond. In one carbon hydrogen bond, their bond energy is 414. Like this way, that's why we get a huge number of heat if when we break down the bond energy of carbon hydrogen. Sorry, hydrogen carbon bond. Now come, there is a lots of bond energy. If you observe, there is nitrogen 3 bond. Why this is 3 bond? We know nitrogen has in outer shell, there in first shell there is 2, and in the outer shell there is 5, and in another nitrogen there is in first shell there is 2, and in outer shell there is 5. That's why they need 3 extra electron to fulfill its outer orbit. That time they used to share 3 electron or except 3 electron. That's why nitrogen when nitrogen makes sorry, it will be here, that time it share these 3 electron and they make nitrogen triple bond. Now here look, oxygen double bond, and here carbon triple bond, and carbon oxygen double bond, carbon oxygen single bond. That means the single bond has the less value than the carbon oxygen double bond. Carbon oxygen single bond, the bond energy is 350 only, and carbon oxygen double bond has the 724 kilojoule per mole energy inside the bond. That is very much important. And when you have to do the math, solve the problems or do the math from this chapter, that bond energy will be given. So no need to memorize, just you have to know the bond energy, and there like this problems, with the problem they will give the bond energy. Like here they give the hydrogen chlorine bond energy is 431 kilojoule per mole. Now come to use of chemical energy. Dear students, transformation of chemical energy into different types of energy. Here when we burning of fuel, when we burn the natural gas, we get light energy, heat energy, and that means here the chemical energy turns into light energy and heat energy, and it produces carbon dioxide, water vapor, heat and light. Now come to fireworks. The fireworks that you see on the sky during the large festival, lights, sound and mechanical energy. That means when we burn the fireworks, we get light, sound and mechanical energy, because it goes to the sky and that time it bursts, and that time we get the light energy. Also we heard the sound, that is this also make the sound energy. Come to dry cell. Dry cell is common things to us. We all use the dry cell as the familiar with battery. Battery is the dry cell, and we already learned about it in our previous class. The battery is used in torch, remotes or dry cell. The chemical ingredients inside a dry cell react with each other, and the chemical energy in them transform into electricity. Now come to Daniel cell. That's the Daniel cell are used in bus, truck, and now we also have in our house as the cell or battery of IPS. Zinc metallistic in zinc sulfate salt solution and copper metallistic in copper sulfate salt solution are used in the make Daniel cell, and their chemical energy convert into electrical energy. Now come to chemical energy and use of various energies obtained from the chemical energy. Dear student, I have told that when plants make their food, they transform the light energy into chemical energy, and the chemical energy is the most used all the kinds of energy on earth, and that chemical energy we take as our food for getting energy. And not only that food, we also using fuels that also are source of chemical energy. That means we get most of the energy from the chemical energy in our daily life. When wood or natural gas is burned for cooking, chemical energy turns into heat energy. The heat obtained from the burning wood is used for making bricks or making earthen pots. Like this way, dear students, in the photosynthesis, the plants have the chlorophyll in their green parts. Chlorophyll helps them to utilize sunlight and conduct the reaction between water absorbed from the earth through their roots and carbon dioxide from the air. Thus, they produce glucose and oxygen. This oxygen flies out from the plants, and this reaction is called photosynthesis. This portion you have to memorize. Then the sunlight that participate in the reaction remains in the plant in the form of chemical energy. I have several this. I have told this is too much important for you. Now come to the chemical reaction of photosynthesis. Here 6 carbon dioxide molecule react with 12 hydrogen molecule, and in presence of chlorophyll, and inside the chlorophyll and in presence of sunlight produce glucose, 6 molecules 1 molecules of glucose, 6 molecules of oxygen, and also 6 molecules of water vapor. Now the body of human and plants can be called chemical energies. Plants get chemical energy from carbohydrate, protein and fats. This energy turns into heat and other energy. Plants and animals use these transform energy to conduct different activities. Now come to appropriate use of chemical energy. Petroleum, coal, natural gas, etc. are the fossil fuel. Besides providing heat energy, burning these fossil fuel have harmful effects on nature, and they produce carbon dioxide. We know the amount of carbon dioxide every year is 21.3 billion tons of the gas is a greenhouse gas, meaning it contains heat, it can absorb heat, not it contains heat, it can absorb heat, and world's getting warmer day by day. Again the carbon dioxide react with rainwater to produce carbonic acid, and this when it comes down to the earth with rain, we call that acid rain. Dear students, here the definition of acid rain and the greenhouse gas you have to learn, which is very harmful for nature. These are the earth with these bad effects to fossil fuel are imposing a threat to the life on the earth. Dear students, come to the importance of purity of fuel. Dear student, when we burn the fossil fuel, a lots of harmful gas is produced, like carbon dioxide, sulfur dioxide, sulfur trioxide, nitrogen dioxide, that all are produced when we burn the fossil fuel, and that gases are harmful for nature. They react with an environment, water and oxygen, and they produce, like carbon dioxide and water produce carbonic acid, sulfur dioxide and oxygen produce sulfur trioxide, sulfur trioxide and water produce sulfuric acid, or here they written sulfur acid, it will be sulfuric acid, and nitrogen dioxide, water and oxygen react with each other and produce nitric acid, and this all acid is harmful for environment. The acid rain cause huge damage to our environment. Plants die, water in the water bodies turn acidic, which makes survival of fish and other living bodies tough. Then the smoke of automobiles consists of carbon monoxide, nitrous oxide and unused methane. In presence of sunlight, these react to create various venomous gases, and this is very much harmful for us. They are known as photochemical smoke. Photochemical smoke is a harmful, huge number of harmful gases which react with the ozone layer of the atmosphere, and ozone layer protect the earth from the ultraviolet ray of the sun, and this is ozone layer. Ozone layer is hampered, life of human will be troublesome. Now come to negative effect of chemical energy. Dear students, we already learned that every year we producing 21.3 billion tons of carbon dioxide gas by burning fossil fuel. Trees takes in this carbon dioxide for when they go through the photosynthesis process, and this is a greenhouse gas, and which one is left, this portion is absorb the heat and it increasing the temperature of world, that and that just melt the ice or glaciers which are in the polar zone, and this is increasing our sea level, and this is known as the greenhouse effect. The greenhouse gases undergo reaction with the ozone layers and harm the capacity. The ozone layer acts as the filter of sunlight in the atmosphere. The ultraviolet ray of the sun is very harmful for our skin, and it may cause the skin cancer. The ozone layer prevents thus ultraviolet ray. Now use of ethanol. Dear students, the other name of ethanol is ethyl alcohol, and formula of it is CH3 bond CH2 bond OH, and this is alcohol that also can used with the fossil fuel as the fuel of the engines of vehicles, and that will make less harmful gases, and in the North America they are used, or in USA they use 10% ethanol mixed fuel for their vehicles, and it is less it is producing less amount of harmful gases. Then ethanol may be a plain substitute of fossil fuels, relieving the pressure on our reserve. Now come to our homework. This is our homework number 1. You have to make 5 knowledge based question with his answer, and you have to submit on Saturday from 9 am to 3 pm. Dear students, I have finished my today's topic. This is too much important chapter, and this is the basic part of the chapter. Read the part again and again and learn all important topic. Thank you. Allah Hafiz.